Okay, today we're going to learn some new function notation. It's just notation, a different way of writing, adding, subtracting, multiplying, and dividing within function notation. The first one, f plus g in parentheses of x, can be rewritten as f of x plus g of x. So really that notation just means add the two functions together. Now we're just going to use this same logic for the rest of the set of symbols. This set of symbols just says subtract the two functions from each other. This set of symbols says to take the two functions and multiply. I'm going to change the symbol just so we can see it a little bit more clearly in between f and g. And this new set of symbols says to divide. Okay, I'm going to now let f of x equal 1 minus 4x and g of x equal 3x plus 1. And I'm going to use the first set of notation, which says just take f of x and add it to g of x. Now I can rewrite it, if you prefer, as the first step. But you don't really need to do this. You can or you don't have to. Then I'm actually going to take f of x in parentheses and add in parentheses what g of x is. I'm going to go ahead and simplify by combining like terms. 1 plus 1 is 2. Negative 4x plus 3x is negative x. And that is f plus g of x. Okay, now we're going to take the difference of the two functions. First of all, we're going to rewrite it in from the old notation, or the new notation, into the old notation. And now I'm going to actually do the subtraction. I'm going to take f, which is 1 minus 4x in parentheses, and subtract g of x. Make sure that you put it in parentheses. The big thing about making sure you put it in parentheses is I'm not subtracting the first object. I am subtracting the 3x, and I'm going to be subtracting the 1. So when I simplify this, I will end up with 1 minus 1, which is 0, and negative 4x minus 3x, which is negative 7x. Now we're going to do the multiplication, and once again I'm going to rewrite it using the old notation. And I'm going to do my substitution. F of x is 1 minus 4x times, make sure you have this in parentheses always when you do those substitutions. And now I'm going to simplify this using FOIL. First, outer, inner, last. Combining like terms gives me a 1. And I'm going to end up with a positive 3x and a negative 4x, which combines to a negative x. And then I will have negative 4x times negative 3x, giving me a negative 12x squared. I'm going to do division. I'm going to start by rewriting it using old notation. And then I'm going to do my substitution with parentheses. F of x is 1 minus 4x, and g of x is 3x plus 1. And that actually is fully simplified now. We're going to begin our conversation about composition of functions. The most important thing to understand about a composition of functions is that it will always be at least a two-step process. The notation. Two ways you can write it. That is not a multiplication symbol. And I really don't prefer to write it in this notation. It's kind of an old notation that's kind of hung around. It's read f of g of x. I am going to immediately, anytime I ever see a composition written this way, I'm immediately going to rewrite it this way. Because this set of symbols is so much easier to read. Now, every function requires one basic step. If you have the input, you can then, in one step, calculate the output. But notice what this composition shows. F of something. That means my output is F. When I plug in this input, I have an input, and the input produces a output. But what's interesting about this input of f is I'm inputting g of x, and g of x specifically reads the output of g. So the input of the function f is the output of another function. Let me give you an application of something like this. For instance, let's say you want to buy a house. And the amount of house you can buy is going to be based on your income. So I will let H equal the amount you can purchase on a house, and I will let I equal your income. And this is an approximation that you could approximately buy 3 times your income on a house. I could look at some figures over here and say, okay, if I had an income of $40,000, that means I could buy approximately a $120,000 house. If I had an income of $100,000, I could approximately buy a $300,000 house. To know how much house you can buy, you must know the income. So, given income, in one step I can find the amount of house you can buy. Let's take a look at something like this. This is an approximation of how much your income will be on your very first full-time job straight out of college. From here, I can calculate the income if I know how much education you have. So from this function, the output is the income and is the number of years of education you have past high school. So, if you have a high school degree and no college education, and you go out and get a first full-time job, you would expect to make approximately $18,000 a year. If you went out and got a 4-year degree, you would expect to make approximately, let's see, 4 times 4 is 16, plus 18, approximately $34,000 a year. Now, what we notice is the amount of house you can buy is a function of your income. Your income of your first job is a function of the number of years of education you have. So, this symbol here read it. The ultimate output will be how much house you can afford to buy, based on an income that will be determined based on you having 4 years of college education. Two-step process. Always at least a two-step process. Step 1, how much income will you make with 4 years of education, starting pay, first job? And our answer to that is approximately $34,000. Step 1, calculate the income. Income of 4 years of education with starting wage of about $34,000. Next step, I now know what to plug into my housing function. I will plug in that 34 as my income, and I can now calculate a house of approximately, let's see, that'll be 102,000. Which means straight out of college you can afford a nice little condo, straight out about $102,000. We're now going to apply this concept of composition of functions on just any random generic formulas. First we must understand how to read it and then apply what we read. So take an example of this. Let's say I asked you to calculate G of F of 4. Okay, that means ultimately I want to know what I'm going to get out of G. However, I need a little work before I get to there. Two-step process minimum. What am I going to plug into G? F of 4. What is F of 4? It's all about literacy. F of 4 is the output of the function f when I plug in 4 into the input. So, let's take a look at this. I'm going to plug in 4 into f of x and take 3 times 4, which is 12. Subtract 7 and get 5. Step 1, I calculated f of 4. Now I know what to plug into G. I will go straight into G and plug in that 5. Now I know how to get my output. Simplify that. 4 times 5 is 20. So G of F of 4 is 20, which means the output of G when I plug in F of 4 will be 20. Also, I can flip the direction. I can go F of G. Let's do of 4. This is very different. It's not the same answer because my process is written very differently. Ultimately, I'm going to end up using F. But before I get to F, I first must calculate G of 4. So to get G of 4, I'm going to plug in 4 into this formula over here, G. When X, my input is 4, my output will be from G. Step 1. Calculate the output from G. Step 2, plug that into F and calculate its output by taking that input, plugging it in, throw that in the calculator, minus 7, and it simplifies to 41. So F of G of 4 is 41. So far, so good. Now, I'm going to take it up one more step. Let's look at f of g of x. My final argument is not only can I go from an input through both formulas and come out with a single output, I'm going to claim now that I can go from formula to formula. So let's see how this reads. I'm going to take the formula f, and in my input location x, let's look at the formula f. Here it is. And in the input location, this is where I plug numbers in, where x is. I'd like to plug in the g of x value. But what is g of x? G of x is 4x. So I'm going to plug that in because g of x is 4x. That's the output of g for whatever I plug in for f. Now I'm going to simplify that. Let's work at the opposite direction. Let's talk about g of f of x. So, I'm going to go from formula to formula because I don't know what x is. I know that ultimately I'm plugging something into g, correct? So we're going to start with what is g. G is 4 times its input value. And what am I going to plug into that input value? The output from f of x. But what is the output of f of x? The output of f of x is 3x minus 7. And again, you need to learn to read the formulas, because this is exactly how this reads. The output of f of x is 3x minus 7. Now I'm going to simplify it. And I get 12x minus 28. We're now going to go to graphs and look at some compositions there. So, first question, given the red graph is f of x, the purple one is g of x, we would like to identify f of g of 2. Really, what are we looking for? The output of f for some given input, but I don't know what that input is yet. So this is what I need to find out. What is that input? Well, let's talk about that input, g of 2. I could interpret g of 2 as being the y value of g, or the output value of g, when I plug in the value 2. So I come over here to x equals 2, and y, it looks like it's going to be approximately negative 2. Now I know what to plug into y. Once I have that, I'm going to find the input of negative 2 and calculate its y value to be approximately 0. Let's look at the other direction. G of f of 2. It's not going to give us the same answer. So I'm going to start off by figuring out, what do I plug into g? And what I'm going to plug into g is f of 2. Well, what is f of 2? f of 2 is the y value of f when x is 2. That y value appears like it's going to be approximately 4. Now, g of 4 reads, what is the y value of g when the x value is 4? So find the x value of 4 and then find the y value of g, which appears to be about -4. So the whole goal is reading what the symbols represent.